Okay, so you guys are now on page 31. Notice the one problem we have there is we're trying to find the derivative for log base 10 of tangent of x. In other words, this is just regular log, right? Usually we don't write base 10 because that's the most commonly used log form. But you guys have earlier in the written part of the notes that if y was equal to log base some number, like b was just some nice positive number of u, where u is some function of x, then we could rewrite y in terms of a different base. And usually the one we want to rewrite it in terms of is log base e, because that was defined as the natural log, right? So log base e of u over log base e of b, right? This is our change of base rule for natural logs, right? Just another nice little log rule that we have. And then anything base e is natural log, so we can rewrite it in this form. Okay, what's natural log of b? That's just a constant, right? Since this part is a constant, I can just take the derivative of this without having to worry about it, right? We can just put that in later. So then y prime, right, what is y prime? We want to take derivative of natural log of u. What was the derivative of natural log of u? That was just u prime over u. But now we've got this 1 over natural log of b as well. So really, you're done here, right? You can just, this is the form you want, right? You might also, move this in front, or you might see it as u prime natural log of b times u, right? Either way, it's done. Okay, now let's see if we can use this for this function. Here we've got f of x equal to log base 10 of tangent of x. Pick a different color. Now, all right, what is u here? What would make sense to pick for u? So you guys choose that real quick. Maybe pause the video, choose your u, and then see if you can find the derivative. Put it in this form. I'm going to let u equal tangent of x. Then what we need is to take the derivative of log base 10 of u. Right? Here's our y equal to this. Well, according to our form here, we should get u prime over log base 10 times u. All right. Well, then y prime is then simply, what is u prime, right? If u is tangent of x, then u prime we found earlier was equal to secant squared of x. So we get secant squared of x over natural log of 10 times u, which was tangent of x. And there we go. There's our derivative, which you could then try to simplify, right? You could rewrite secant squared and tangent in terms of sine and cosine, but you're pretty much done here, right? You could rewrite this if you'd like. Which, let's just see what happens. What the heck? So secant squared I could rewrite as 1 over cosine squared. Tangent I could rewrite as sine over cosine. Notice I've got two fractions here, and I could pull that constant out if I like. What do we get here? We get 1 over natural log of 10 times, right, this becomes cosine over sine. So if you're so inclined, you could rewrite this as 1 over natural log of 10 times 1 over cosine sine. And then you could rewrite those two as secant and cosecant as well. But really, we were done back at step 1.